All right, you guys, we're going to continue on with page 2 by starting with number 17. The directions for this set of questions says to find the indicated information and show the proportion used and the work. When we look at these two triangles, I know they're similar because of corresponding angles. So we're looking at the little triangle and the whole triangle. So if I highlight these individually, we're looking at the top and the whole outer piece. Information we have on the big triangle is this whole left side is 20, and this portion is x, and this portion is 6. The first thing I want to do is find what the whole side on the right is of this triangle. X and 6 are going to add together to get me x plus 6. X represents in the little triangle the right side, and on the left side I don't have a value. But what I do know is that this whole side is 20. Part of it is 8, so I could do 20 minus 8, which is 12, to figure out that the upper part of that triangle is going to be 12. Now we have enough information to write a proportion. So what I'm going to do is I'm going to compare the little triangle over the big, so we'll do L over B. And I'm going to look at my whole ratio. Right now I have 12 comes from the little triangle, and the whole side of the big triangle is 20. And it should be equal to the little side of the triangle on the right over the whole side on the right of the big triangle. So now we can cross multiply. Since this is a group, I'm going to put it in parentheses. We're going to have 12 times x plus 6 equals 20 times x. When I distribute this, we get 12x plus 72 equals 20x. When we take our 20x and subtract out 12, we get 72 equals 8x. And when I divide 72 by 8, we're going to get x equals 9. So 9 is our final answer, which means the little side of the triangle is 9, and the whole side would be 9 plus 6, which is 15. That's not what it's asking for, though. You just want x. All right, number 19. Again, same kind of problem. We have corresponding angles, which mean our two triangles are similar. One triangle we're looking at is the upper triangle on the top. The second triangle we're looking at is the whole triangle in the picture. So pieces that we have x, we have 18, we have 6, and we have 24. We also have y and 35. This one really only asks you to find x though. So we could do, one thing we notice about these two is the fact that these sides are parallel. If that's the case, then each of the pieces could be written as a proportion because the sides are split proportionally by these parallel lines. So let's say we do top over bottom. So we'll do top over bottom for our proportion, which would be x over 18 equals top over bottom 6 over 24. Remember, it doesn't matter what order you choose to start with, but whatever you start with, you have to finish the proportion out with. So don't do top over bottom and then bottom over top. It has to be the same on top and the same on bottom. So from here, we'll cross multiply. 6 times 18 is 108. 24 times x is 24x. And when you divide both sides by 24, we're going to get x equals 4.5. All right, looking at number 21. Number 21 is a turned triangle. I know that these are similar because of angle. I have alternate interior angles as well as vertical angles. I'm going to put those in there, those marks, also not only to see that they're similar, but also to see which sides correspond with the other triangle. So when I look at this, side 15 is connecting the one arc to the two arcs. So it would be matching the y, which connects one arc to two arcs. So 15 and y go together. Then I would look and see that 20 connects two arcs to none. So then I find which side connects two arcs to none, which is x. So 20 and x must relate to each other. And then my last piece is the parallel sides. The parallel sides are 10 and 6, so they're going to relate to each other. First thing I'm going to pull out is my complete ratio. My complete ratio is 10 and 6 because those are the two corresponding pieces that I know both of. So from here, let's do big over small for this one. So big over small would be 10 over 6. Since we want to find x and y, let's just find x first. So the x ratio is x and 20. The big number, though, coming from the big triangle is 20. So 20 goes on top and x goes on bottom. Then I'm going to cross multiply. 10x equals 6 times 20 is 120. When you divide that by 10, you get x equals 12. Now we're going to write the same proportion, but define for y. So we'll do big over small again. We'll use our same ratio that we did before, 10 over 6, except now we're going to compare y and 15. 15 is from the big triangle, so it goes on top. So it would be 15 over y. We'll cross multiply and get 10y equals 6 times 15. 6 times 15 is 90. When you divide both sides by 10, we're going to get y equals 9. All right, number 23 is another similar problem, similar triangles problem. The first thing I notice is that my sides are parallel, so I know that my sides are split proportionally. So I can do top over bottom to find x. The left side, top over bottom, would be 3 over 4 equals. The right side, top over bottom, would be 8 over x. So when I cross multiply this, I'm going to get 3x equals 32. And when I divide by 3 on both sides, we end up getting 10.6 repeating. Now for y is the bottom of the triangle, the bigger triangle. So again, we're looking at overlapping triangles where the top one has sides 3, 8, and 10. And the big triangle has a bottom of y and then a whole side of 7. So let's compare the left side to the bottom of the triangle in a proportion. And we will start with the little triangle and go to the big. So we're doing small triangle over the big. So we could do 3 over the whole side. The whole side of the little is 3. The whole side of the big is 7. Set it equal to the bottom of the little to the bottom of the big. So 10 over y. So we'll cross multiply this. We get 3y equals 7 times 10 is 70. And then 70 divided by 3 gives us y value of 23.3 repeating. All right, you guys, let's look at the next page, which is the last page. Number 25. We have 3 parallel lines that are cut by 2 transversals, or cut by 2 different lines. And what happens when you have parallel lines all crossing the same lines is that it cuts those lines into proportional pieces. So there are several ways to set this up. One way that I saw was top over bottom. So I'm going to do top over bottom. Top over bottom on the left side would be 9 over 6. Top over bottom on the right side would be x over 14. So we'll cross multiply. 6x equals 9 times 14, which is 126. And when you divide that 126 by 6, you end up getting 21. All right, number 27. We'll zoom in a little bit so you can see a little bit better. Number 27 has 2 triangles. I know they're similar because we have angle-angle similarity. So I'm going to identify the corresponding parts so I can find x and y. Let's start with 15 because this is the first side I can quickly figure out. It's between one arc and the double arc here. So it would match with the side between the two arcs on the other triangle. So X and 15 are a pair. And then I'll move to Y, because that's the other one I need to know. Y comes from the double arc to a blank empty angle. So double arc to blank angle in the other triangle is 40. And the last side must go together, but the reason is because it's coming from the one arc to the blank, one arc to the blank. So 20 and 12 go together. One thing I notice is that 20 and 12 are my full ratio. So I'm going to do, let's do left over right. So left over right with 12 and 20 would be 12 over 20. And if we wanted to find X first, X is pink. Left over right would be 15 over X. When we cross multiply this, we get 12X equals 20 times 15, which is going to be 300. And when you divide 300 by 12, you end up getting X equals 25. Now we're going to use that same beginning ratio of 12 over 20 to set up a proportion for Y. We're still using the left over the right. So left over right with Y would be Y over 40. And then we'll cross multiply. So we get 20Y equals 12 times 40, which is 480. When you divide that by 20, to solve for Y, we get Y equals 24. All right, guys, let me zoom out a little bit so y'all can see 29. All right, number 29 says that the dimensions of a parallelogram are 6 meters and 10 meters. So when I draw a parallelogram, one of the dimensions is 10 meters, the other is 6 meters. And we want to find which of the following are similar dimensions or dimensions of a similar parallelogram. Well, we first need to find the ratio of those sides. Let's do long over short. So this would be 10 over 6. But let's reduce it just to double check that we're checking each piece. So this would be, they're both divisible by 2. That reduces to 5 over 3. So this is the ratio that I'm looking for. I want to see which one has the same ratio. So we want to check big over little. So for part A would be 30 over 12. 30 and 12 are both divisible by 3. So if I divide out by 3, we get 10 over 4. I can divide out again. They're both divisible by 2, which would give me 5 over 2. 5 over 2 is not the same as 5/3, so A is not similar to my object. Let's check B. Big over little would be 15 over 12. 15 and 12 are both divisible by 3. So if I divide that out, that would be 5 over 12 divided by 3 is 4. 5/4 is also not the same as 5/3, so B is not an answer choice for me. Let's check 15 and 9. 15 is the big. Big over small would be 15 over 9. Those are both divisible by 3. 15 divided by 3 is 5. 9 divided by 3 is 3. This one definitely works. So C is definitely an answer. Let's double check D just in case there's double answers, like multiple correct answers, or if in case I did my work wrong. Big over little would be 12 over 8. They're both divisible by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. 3/2 is not the same as my original 5/3, so D is not an answer choice. So my answer is C. All right, last question, number 31. We have a basketball player who is 2 meters tall. Here's my basketball player. He is 2 meters tall, and he's casting a shadow, which would be on the ground, that's 1.6 meters. At the same time and place, a flagpole casts a 4.4 meter shadow. We want to find out how tall is the flagpole. Well, here's the deal. These should be similar in order for the sun to be casting the same shadow at the same time in the same area. So let's come up with a proportion. We could do left over right and left over right. So let's do, let's start with the height of your person, your basketball player, and your flagpole. So that would be left over right would be 2 over x. And that should be equal to left over right of the shadows, which would 1.6 over 4.4. So we'll cross multiply. 1.6x is equal to 8.8, which is 4.4 times 2. And then when we divide that 8.8 by 1.6, we end up with an answer of 5.5, which is representing the height of the flagpole. Since our units are in meters, the height of my flagpole would be 5.5 meters. All right, you guys, don't forget that there is always tutoring. Ms. McKeever and I have tutoring Tuesdays and Thursdays, morning and after school, and y'all are welcome by anytime. Good luck studying for your test.